So let's talk about adapting these adaptive controllers from the Microsoft Adaptive Hub setup. As they sell them, you can get three different tops: the joystick, a D-pad format, and a AB push button. And as I showed in previous videos, these are pretty much the same hardware across the board. They have this tabbed design where the tabs click into place into the slots on the controller. So yes, you can replace them, but my big concern is that with a traditional 3D printer like most folks are going to have, like my Prusas, which print in PLA or PETG or even nylon, it's going to be hard doing some of these edges in these shapes. Now, a resin printer will probably be able to do a lot better job, and I have to find somebody with a resin printer who could try this out for me, but I don't have one. And so I was kind of disappointed. I was disappointed that they didn't have STL files available, and that in order to get different versions of these toppers, you have to basically buy them from Shapeways. I get it, they're in business, I appreciate that. But I'm also the sort of guy who, if I'm going to complain about something, I'm going to do something about it. So I decided I'm going to do something about it. What I did is I took a look at these, and I got out my dial calipers, and I started doing what I always do with my favorite tool in the whole wide world. This is my version of a slide rule. Is I just start measuring the heck out of everything. I start measuring the slot thicknesses. I start measuring distance, all things, because I want to get an idea if I want some sort of model of this, and I don't want to look for their CAD CAM files if they're even available, which I would doubt, unfortunately. Anyhow, let's talk about solutions. So I looked at this and I thought to myself, you know what? This reminds me of stuff done in the past, and I learned it from somewhere. I can't remember, but for locking things into tabs, one kind of interesting way of DIYing it is if you have a screw that will fit into here. Well, actually, thinking about it now, how about all those inexpensive lights you hang that have the little keyhole cut out? It's the same idea. You put the screw in the wall and you drop the unit in. That's where it came from. See, now I know. When you talk about it, you learn. So when I looked at it, I measured this. It's 1.6 millimeters across, roughly, at this narrowest point. It's about 42 millimeters across the diameter. And I said, 1.6 millimeters? Well, that's not an uncommon metric measurement. And I happen to have 1.6 millimeter tiny little screws around. And in this little, it's probably so small, there it is, 1.6 millimeter screw, that's 5 millimeters long. And so I printed out I designed a disc, just a circle, right? And it's about 8 millimeters thick or so, maybe less. Oh, you know what? I have my tool right here, I could tell you. It's 4. See, I was wrong. Anyhow, what I did is on 42 millimeters on center along the circumference, I have holes, and I screwed in these little tiny screws. And believe it or not, when you do that, it will fit into their slots and work like that. And I've had these on and off these several times. I haven't broken it yet. Now, what I did order and I didn't have on hand, and I was amazed that they have, is they do have 1.6 millimeter brass heat inserts that I could put in here that I ordered and will be arriving some point. That'll strengthen that up, and I'll probably hit it with a little bit of super glue to keep them from coming loose. But I think it's going to be pretty strong. And honestly, these tiny little metal screws are going to be stronger than the plastic. So what do we have now? Aha, we have an adapter. As I keep it simple, I used an M4 screw M4. Had it on hand. M3 seemed a little too small. M5 was overkill. I have more M4 inserts, so I went for this one. Now this one is, I think, about 8 millimeters. Well, plus the head. Yeah, it's 8. So I countersunk it just slightly, about a millimeter or two, so that I could always hit it with glue so it doesn't come loose. Because the inside of here, you could see it's scooped out, so I have clearance without having the countersink. So I could keep this relatively thin and not have to worry about that breaking. So now I have a screw, so I do the twist, locks it in place, and now I've got a nice flat surface, and I've got an M4 screw sticking out there, at least, let's see, 4 millimeters. That's not a bad distance. Now here's where it gets cool. Now you could start doing kind of normal 3D printing of stuff. So here's a stick, a little tiny knobby stick. Here's one of those half moons. If you've seen my palm sticks, it's the same idea there. And here's a crazy circular one that I did. Now these simply screw into place. Boom, 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 you're done. Okay, that doesn't work for a user. Well, okay, now let's try this one. Blue, 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 screw it on. Well, that's too it's too pointy up there for them. Okay, that's fine. Let's put the stick on. Oh, yeah, that's a better feel. So I think I've got to the point. I'm really close with this prototype. It is a prototype. The idea of using the little screws, is it the best idea in the world? No, I don't think so. If I could get them, I would get tiny little metal rods, like almost like giant thick pins that are smooth-sided. But I tried looking. If anybody can fit little 1.6 millimeter pins with heads on them, please let me know. They need to be about 5 or 6 millimeters in length. But for now, this has been working out. And the beauty of all this is all stuff you can get on Amazon. I mean, even these crazy size screws. Oh, and I should show on the bottoms of all the joysticks, I have heat pressed in an M4 insert. So these you heat it up with a soldering iron. I have a special tip that I put on a soldering iron, and it bloop, melts it right into the plastic and stays in place. Now you've got metal on metal, which is always, in my opinion, a good idea when it comes to stuff that's going to take a lot of abuse. So you have metal there. You could even make the disc out of metal if you had the machine shop for it, but I'm trying to stick with 3D printing. So there you go. Now you have an adapter for the adaptive controller, and you can mess around with it, and you don't have to order things from Shapeways, and you can just go right at it. So I hope that this has been helpful. I really look forward to your feedback. I want to hear ideas on how to improve this. I think that this is a great little device. I think it has a lot of possibilities, and I think that the maker community can really bring to it that a little bit more that it needs. So please give me your feedback. And if you like the work that I'm doing and you want to help support me, there's a couple of ways that you could support me. As always, you could take a look at my Etsy site and see if there's a joystick or other input device that you'd be interested in. I also take any sort of cash donations through all the usual suspects. Any donations that I get go directly into buying this sort of hardware, the parts needed to do this sort of rapid research and development and rapid prototyping, because that's really the key here, is rapid prototyping. So thanks very much for watching, and I'll talk to you soon.